here is our question, and you see here we can write hx, you see hx, and this can be rewritten as, I show you, the exponential series e to the power x, and if we use, then hx will be 1 plus x square by factorial 2 plus x to the power by x to the power 4 by factorial 4, and so on. There will be infinite number of terms. So our hx sin theta, you see inside the integration sign, after integration sign there is hx sin theta. We can evaluate this one, and this will be accordingly 1 plus x square sin square theta by factorial 2 plus x to the power 4 sin to the power 4 theta by factorial 4, and so on. There will be many terms, but we don't need in this all terms. We can find easily taking 2 or 3 terms. Okay, so here we find fx. So fx will be, you see fx is an integration, and this will be equals to 0 to pi, and here is first is 1, so here will be 1 d theta, and thereafter the second term will be x square by factorial 2. X square by factorial 2 is will be taken out, because for the integration x is constant. Okay, and here will be sin square theta d theta 0 to pi, and the third term will be x to the power 4 factorial 4 sin to the power 4 theta d theta, sin to the power 4 theta d theta, and here will be the integration from 0 to 4, and there will be infinite number of terms. Okay, now let us evaluate, and to evaluate we need this one. I show you in red this formula. We need 0 to pi sin to the power n sin to the power, not 4, here will be n theta d theta, and if you assume it to be in, then in will be equals to n minus 1 by n minus 2, and this is a recursive formula. If you put n equals to 2 in this, then we have I2, and this will be 1 by 2, and here will be I0, means 0. We have to put here in this n equals to 0, and that will give us pi. So I0 will be pi, so I2 will be pi by 2. Okay, and similarly if you find I4, then I4 will be, I write here, I4 will be 1 into 3, 2 into 4 into pi. Okay, you can check that, very easy. If you know this formula, then very easy you can do. You can find I4, I6, but I said that there is no need to go for I6 and I8. 3 terms are sufficient. Okay, so our fx will be, fx becomes pi plus sin square theta d theta 0 to pi is I2, and you see in red I2 is pi by 2, so here will be pi by 2, and x square by factorial 2 is already there, and here the value of this integration I4 will be 1 into 3, 2 into 4 pi, and x to the power 4 by factorial 4 is already there, and plus. Okay, So we have this is our fx. Remember that this is our fx. Now we need here, you see in the options, in all options, f double dash x, f dash x. So we find these derivatives. Okay, so first we find f dash x. So I write f dash x in green. So f dash x is very easy. Differentiating we can find, and that will be pi by 2 x plus 1 into 3, 2 into 4, pi, and x cube by factorial 3 plus, and so on. Now we I write now f double dash x in red, and this will be pi by 2 plus 1.3, 2.4, pi, and differentiation of x cube by factorial 3 will be x square by factorial 2. Okay, plus plus plus. So now we compare. Here you see in the options with f double dash x is attached. Okay, and also you see fx, with fx x is attached in all options. You see here in all options. So we have to multiply f double dash x with x and f x with x. Okay, so we compare taking the first term only. I show you in yellow color. Okay, so here is our fx, this is our fx, and according to question we have to multiply with x, and I just take the first term of each. So if you multiply this with x, so that will be pi x. I write here. Okay, pi x I write in red, pi x. Okay, so I took the first term, and this is for this. Okay, so I took the first term of x fx. Okay, this is for x fx. Now I take the first term of x f double dash x. You see here pi by 2. Okay, so to get the first term of x double dash x, I have to multiply this pi by 2 with x. So that will be pi by 2x. Okay, now it remains f dash x, and you see here first term of f dash x is pi x by 2. So I type here pi x by 2. Now see these 3. Okay, we have to put the signs. So what will be the sign? So that you see here options, in all options there is 0 after the here we have to place the signs here. In these 3 we have to attach sign plus or minus, so that the result will be 0. And first thing you have to keep in mind that with x f dash x, in all you see there is a plus sign. So the first term will get plus sign, so here will be plus. Okay, for the first it will be plus, and now it remains the 2. So for 2 we have to attach signs, so that the result of these 3 will be may become 0. Okay, and for that I show you here. I place plus. Okay, plus, and here I place minus, then obviously it is 0. See carefully. So what I did, I placed for the first plus, for the second plus, and for the third minus. So the signs are in the sequence plus, plus, minus. Now see the options. Here you see all signs in plus. Here you see we have to find plus, plus, minus. Here is not plus, plus, minus. In C you see plus, plus, minus. For in the first term you see plus, in the second it is plus, and in the third it is minus. So the correct option, so our option to be marked is C. Okay.